Question 1. It's a question where we have a study of students on campus, categorized by what class they're in, and whether they have a car or don't have a car on campus. And so this table gives us all these numbers, and we see there's a total of 1,510 students attending this school. Now, 486 have cars on campus and 24 don't. And then this column gives how many are in each of the 4 classes, freshmen through seniors. So the first part is, what is the probability of randomly selecting a student who is a sophomore? In other words, what's the probability of sophomore? By the way, that's the same question as what proportion of the students are sophomores? It's the same answer. What's the probability of randomly selecting a student who's a sophomore? Or what proportion of students are sophomores? Well, we count up how many sophomores there are total, 410, and divide by the total number of students, 1510. So the answer is 410 over 1510. That's the answer to part A. Now, what's the probability of randomly selecting a student who has a car? Well, how many cars? 46. Out of what? 1510. So 486 over 1510. Now, that's question part B. Part C. What's the probability of randomly selecting a student who is a sophomore and has a car? So car and sophomore. And means overlap. Now, what's the overlap of car and sophomore? 80 out of 1510. That's the answer to part C. And means intersection overlap. Oh, here we go. What's the probability of randomly selecting a student who is either a sophomore or has a car? Or well, here's the deal. We have to use the formula. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So, here we go. The probability of car plus the probability of sophomore minus the probability of car and sophomore. And we've calculated all of them. We got 410 over 1510 plus 486 over 1510 plus 80 over 1510. I'm sorry, minus. Ah, there goes my Academy Award. Okay. So, 410 plus 486 minus 80 is 816 over 1510. Any questions so far on A through D? are you all too camera shy to speak up? Okay. Part E. Given that a randomly selected student, given conditional probability, given a randomly selected student is a senior, what's the probability that student has a car? Well, what's our motto here in Stats 150, Section 6? Use what fits the given. Use what fits the given. And the given is, the student is a senior. Please allow me to circle in green what fits the given. Those would be the seniors. Okay? Don't worry. When I post it online, I'm going to fill in a lot of gaps with canned applause. This will be just like Seinfeld. Okay. So, given the student is a senior, that's why I'm wearing my white sneakers. This is going to be just like Seinfeld. Given the student is a senior, what's the probability the student has a car? Well, what fits the given? 220 have a car out of 250. So the answer is 220 over 250 for the probability given a senior, the probability of a car is 220 over 250. Don't be putting 1510 in the denominator. Don't do it. Use what fits the given. Now, what fits the given will be a row, or perhaps more than one row, or it might be a column, or more than one column. Okay? Any questions on that conditional probability? We have a cameo appearance in our meeting. You won't be getting any payment from the union by walking into our video. All right. The last question is about mutually exclusive, which is the same as disjoint. Two events. Event A, let's say, randomly selecting a student who is a freshman and selecting a student who has a car. Are those two events mutually exclusive? Yes, they are. And why is that? The overlap is 0. Here are the car people, this column. Here are the freshmen, this row. The overlap is 0. Thus, because the overlap is 0, it means it's disjoint. Those two events are disjoint or mutually exclusive. Any questions on question 1? Okay, let's roll the credits.